Good morning, folks. Thank you so much for joining us today on GCP Live. As you can tell, our theme song is still very much a work in progress. Hopefully, by the next session, we'll do a much better job of that. I'm incredibly happy to be joined today by, and I'm going to work really hard to say his name correctly. Robert, you'll correct me if I have it wrong. Robert Kreuzer from Channable. Thank you so much for being here today.
Thank you, Yuri. Glad to be here.
Awesome. So I'm actually really excited about this topic because whenever I talk to folks about GCP, one of the main questions I'm always getting is, hey, looks like you guys have really great technology. We're really interested in either exploring it piecemeal or maybe even moving wholesale, but we have a whole lot of stuff that's already running on premise or possibly running somewhere else. And we're kind of afraid of doing the migration. We're afraid we're going to break stuff. We're afraid we're going to disrupt the service quality that we're providing. And I'm really happy that Robert is here today to tell us how they did it without any of those disruptions and without bringing their site down. So Robert, can you introduce yourself to our audience?
Yeah, sure. I'm Robert Kreuzer. I'm one of the co-founders of Channable, and I'm responsible for all the technology and manage the development team. And I was also overseeing our migration to GCP. And I'm going to tell a story basically of how we moved from our old hosting provider to GCP without any downtime.
Awesome. Really excited to hear that. But I think where we should start is by talking a little bit about Channable. So maybe you can take just a couple of minutes, tell us about what Channable is, what it does, and how it does it.
Sure, I can give a quick demo. I'll just share my screen.
There it is.
Okay, perfect. I'll show you here. This is Channable. Basically, this is the screen after you log in. So what we do is we're a data feed management tool. So we allow people to manage their data feeds and to export their products, like shopping products, to different marketplaces and price comparison sites. So if you want to sell your products on, for example, Google Shopping, you can do that using Channable. So we have, for example, a demo account here. You can think of it basically as one project per web shop or one project per language. If you have a web shop with several languages, I can go back one screen. You could see this would be like the German shop, the French shop, the Dutch shop, and the British shop. And the important part is so that we need to import your data. Then you can optimize your data, and then we can push it to different channels. And I can walk you through that process real quick. Basically, this is the dashboard. This is an overview of how many items are imported. And this is not an example shop. The numbers are randomly generated. And here's a quick overview about how many items are imported and how many items we export to each of these channels. So you can see Google Shopping down there, 145 products. You can also import revenue data and see, for example, how much you make, how much you earn per channel. And this way, it helps you decide which channels are working well. Say, maybe Facebook is going really well, or Jobzilla or Google Shopping. And actually, this data is based on Google Analytics. So you can link your Google Analytics to your product feed data. But first, of course, you have to import your data. You do that based on, for example, a data feed that you already have, like an XML file. But it could also be a different data file like CSV, or we can also import a Google spreadsheet directly. That's also a possibility. Additionally, of course, we also connect with all the big web shop platforms like Magento and like others. Is it clear so far?
Yeah, very much so. I mean, I can certainly see how, if I'm trying to sell a product, let's say I create I invent something and now I'm trying to figure out what to sell it. Like, obviously, I could just take it directly to eBay or something like that. But if I'm really trying to kind of have a global reach for my product, and I've got manufacturing and supply chain all sorted out, then using something like Channable to actually get my product out to the market in a kind of a global way seems like a no-brainer.
Yeah, exactly. So the big selling point is that we support like hundreds of different channels. Like here, you just see a selection of the possible channels that you can export to, but there are hundreds more. And we also support a lot of countries worldwide. And one of the important parts is that we can optimize the data. So basically, after you imported the data, you'll get an overview of what the data looks like. And sometimes this data is not optimal. And maybe you want to adjust the title or the price. You want to say, maybe if I sell something on eBay, I want it to be 10% cheaper. And you can do so using our rules. So basically, if you go to rules, then you can do a lot of things. It's a very powerful way to optimize your feed data. You can, for example, filter out products that don't have an image link. You say, if image link is empty, then take all fields and exclude. So this way, these products will not show up in the final Google Shopping feed. And this is, by the way, the export mapping. So the blue fields are the ones that are in the Google Shopping specification, which are mandatory. The orange ones are the recommended fields, and the gray ones are the optional fields. So this way, you can map all the required fields by just assigning the appropriate fields that is in your feed. And so using rules, you can make sure that the data is optimal. For example, you can remove HTML. You can add some check about which colors are available, or you can show if something's not available, you probably don't. Then you don't want to sell it. You don't want to put it in your feed. Then you can remove it. Or additionally, you can set it to a value. You can set it to out of stock. So these rules are very powerful. This way, you can have optimal feeds for all channels, because of course, all these channels have different requirements. One other thing, we also support APIs. Basically, you can export to Amazon or to eBay or a couple of others. And the difference here is that we can push directly. And for feeds, we generate a data feed, which has to then be imported by the export channel. Finally, we also support Google AdWords. You can actually generate an AdWords campaign dynamically from all your product feeds. So imagine you have 1 million products, and then you want to generate an AdWords campaign. This is a lot of work to do manually, of course, so it's better to automate it. And again, you can first use rules to filter only those specific items that you want to advertise, and then we will only push those ads to AdWords. And using ad templates, you can get very dynamic ads. So these blue fields are basically fields out of your product feed. And you can put in whatever you want. So if you want to advertise on brand, you just put brand there. And this will be filled in with all the dynamic fields from the feed itself. The same is true for keywords, negative keywords, and so forth. I'll just show a quick preview. You will get, in this case, you would just get one campaign, but you can also dynamically generate many campaigns if you want. You can generate a lot of ad groups, a lot of ads, and it's all directly depending on the data in your feed. So this way, it automates like a lot of tedious work. And additionally, we make sure that the data stays synchronized every day, that every day you see the same, that every day only the up-to-date information is sent to AdWords. That was a quick overview. Was that clear?
Very much so. So thank you for doing that. Again, really, it seems like a really compelling value proposition for you in the world. So as should come to no surprise to our audience, Channable is now running on GCP. So before we get into kind of how you made that happen, perhaps you could tell us a little bit about how how did you choose Google Cloud and kind of what went into that decision?
Yeah, sure. We had of course a decision process here. We first of all, we had looked at our requirements because we had some issues with our old hosting provider. Like we sometimes had, for example, network connectivity issues where some of our servers couldn't reach other servers, or even worse, they could still reach them, but only at very slow speeds, which is hard to debug. And also we had problems with like servers occasional restarting. So there were some reliability issues. So one of our main requirements was we need a very reliable hosting partner where we have great networking options and where, uptime is not a problem. So that was one of the big requirements. Also, we needed a good way to automate everything. via an API. We wanted to be able to spin up servers quickly, and we want to be able to declaratively describe our infrastructure to exactly say which servers we want, how they should be configured, how they are connected. All of these things should be very easy to do, and that was also a bit a problem with our old hosting provider. So we looked at the three big clouds. We looked at Amazon, we looked at Google Cloud, and we looked at Azure. And so there were three big reasons why we in the end decided to go with GCP. Well, one was that we had actually already been using Google Cloud Storage for a while before we started using GCP itself. Like, we'd been hosting a lot of files on GCS. It was working well for us. And one technical reason was that GCS actually offers strong consistency. If you want, you can configure it to be strongly consistent, meaning every single file that you upload or overwrite, and then afterwards do a get, you will always be guaranteed to get the latest version. And this was an important requirement for us. And for example, S3 does not offer that. Another thing we looked at was the developer experience and how smooth the API worked and how much you could automate things. And this was also a big plus point because you can basically automate anything on GCE. The G Cloud tool is also very convenient to query your infrastructure and also to change things. And of course, there's also an API which you can use to change anything you want, basically. Last point was that the pricing is actually pretty simple on GCP. It's easy to understand. Basically, if you keep on an instance running the whole month, you'll get a 30% sustained use discount, which is nice. And you can reserve number of CPU cores and RAM, like, to save some money, which is very simple. Basically, just say I need a specific number of cores and a specific number of RAM, and you can divide them any way you want over different servers, which is also very nice. So I think those were the big three reasons to go with GCP.
Excellent. So unfortunately, there's a bit of quality issue. So I'm going to try and summarize, make sure I got everything that you said. It sounded like kind of the two of the biggest problems. We use things declaratively, so using things like Terraform. And then the third major reason why you chose GCP was just simplicity in pricing, and then things like the automatically applied sustained use discounts. Did I capture that correctly?
Yeah, no, that was exactly right. Yeah.
Okay, very good. So now that we know how you chose GCP, tell us how you moved from your hosting provider to Google Cloud.
Yeah, sure. I have actually, so we wrote a whole blog post about this, which can be found on tech.channable.com, but I have a small presentation now where I can walk through it. So I'll share my screen again.
Yeah, that would be great. I think our audience is, folks are always interested in hearing how other people went through the process that they're considering. So yeah, I think this would absolutely be helpful for them.
Okay, can you see my screen?
I can.
Okay, well, basically, it's very simple. So we had a number of servers in our old data center, let's call it DC1, and we wanted to move all of them to our new data center in GCP, let's call it DC2. And there are roughly two big ways to do this. Like, one, I would call the Big Bang migration, where you replicate your entire data center, all of your infrastructure, all of your services in the second data center. Then you pick a date, and then you do a cutover where you go from everything's running in DC1 to everything is running in DC2. This is the Big Bang migration. The second way, and I'm going to make in this talk the point that it's usually the better way to go, is a continuous migration where you continuously move one service from the old data center to the new data center. So here on this slide, basically the little hexagons on the left represent services. So it could be one of your internal applications, one of your, could also be a database server, or for example, we run Redis, we run Postgres, we use HDFS. So it could be one of those. And for a continuous migration, you basically go and move them one after the other. And then if after you moved it, you can run a number of tests. You can be like, check if everything is still running, if everything's working. And only if everything's working, then you do cut over just this one service. Another big advantage is if things go wrong, you quickly can switch back. because the key is that you always run the same instance twice. So by moving over, I basically mean you will run a database server in data center 1 and the same database in data center 2, and you will make sure that the state is continuously synchronized. So important part is that they have exactly the same state at all points in time, of course.
Robert, let me just interject for 1 second, because I think part of what you said had just dropped out, and it sounded pretty important. You're talking a big advantage of doing this because, and then the part after because cut out. Can you just repeat that for us?
I didn't catch the whole question. Could you repeat?
Sure. Tell us kind of why, what is the big advantage or the big reason to move server?
Yeah, sure. I can explain that. So a problem with a big bang migration is it's very high risk, because you need to move all your services at once. You need to test everything. Everything needs to be working perfectly before you can do the big cutover. But making sure that, we run a complex distributed application consisting out of tens of different services. Making sure that all of this is working correctly is very hard. One way you could do it is to capture all of your production traffic and try to replay it on the second data center. But that is a lot of work. That could literally take months just to test everything. And so it's better to then instead move one service after another and test each individual service. And then you know for sure that that service is working correctly. And then after, you do it step by step. Was that clear?
Absolutely, and thank you for clarifying that.
Yeah, the other really big advantage is for a continuous migration, if you do it right, you don't have any downtime. Like if you do the big bang migration, then you will have downtime because you will have to copy all of your state. You will have to move all of your databases. And the thing is, you have to literally stop service on data center 1, because otherwise there will be updates which you'll lose. So you'll have to stop all services, copy everything, and then continue. And this can take, if you have a lot of data, this can take a lot of time. So you could be down for a day or two even. And this was not an option for us. We didn't want any downtime, ideally. A big question is, how do you communicate securely, right? If you just move one service, that means all other services are still in data center 1, but they want to talk to services in data center 2. So there needs to be a secure way to communicate. And the way this is typically done is via a VPN, a virtual private network. This is also what we did. And we used an open source software called Zero Tier. And this was very helpful in this transition. The great thing about Zero Tier is that it's peer-to-peer. After the initial connection, every server in data center 1 will be able to talk to every server in data center 2. And it will be peer-to-peer, and it will not go through a central gateway in each of the data centers. This actually also helps with latency and throughput. So because one question people of course have is, if you run an app in 2 different data centers, isn't it a problem in terms of latency and throughput? But in our experience, this wasn't a problem at all. We measured latencies less than 10 milliseconds on average.
Let me ask you one question. One of the things that people, I think, do have concerns with, even with VPN tunnels, is throughput, bandwidth. And so, people definitely have the option of using multiple VPN tunnels to kind of improve that throughput. Can you give us a little bit of insight as to
Yeah. So basically, what I was just saying. So this whole problem basically was solved by Zero Tier for us, which it works peer-to-peer. So instead of having one big VPN tunnel where all traffic has to go through, you instead basically can route traffic directly from one node to another. You don't need a gateway server, and this way you also get higher throughput.
Got it. Thank you. That helps. Let's continue.
Yeah. So the neat thing about this setup is that basically you have an internal subnet in data center 1, which I called 10.1.x here, and you have an internal subnet in data center 2 called 10.132.x. But additionally, every server will get an extra network interface with 10.144.x. So every server in both data center 1 and data center 2 will be in the 10.144 subnet. So on this IP address, any server will be able to talk to any other server. And this is the prerequisite of moving a service from one data center to another. Because, of course, the second you move service A to data center 2, then all the servers that consume this service in data center 1 still need to be able to talk to that service. And this is then achieved using a different IP address. Then you have to use the 10.144 IP address. And so the next question that people will probably have is, well, how do I manage then my IP addresses? I mean, you don't want to hard code IP addresses. You'd like to use DNS to do service discovery. So this is the next slide. There's another open source project that we use from HashiCorp. It's called Consul. And it's basically a service that it works as a DNS server, and you can use it for service discovery. Basically, every service in your infrastructure will get a DNS name. Like here, I took as an example Postgres. So it will get a URL like postgres.service.dc1.consul. And basically, all services that consume Postgres will connect based on this URL. And so if you then additionally have a Postgres server in the second data center that's available on postgres.service.dc2.consul, then you can easily switch by just reconnecting to that host name. And so the way we did this is that we had a primary database server running in the first data center and a secondary database server running in the second data center. And the secondary server is synchronized. Like all the data is completely synchronized between these two servers, meaning if you do a cutover, there will be no data loss. Like you can use additional tricks like queuing up writes based, if you use, for example, we use a tool called PG Bouncer to do load balancing for database requests. So using this, we could then make sure that all requests we did a cutover, but all requests in the meantime were queued up and then were redirected to the new primary server in the second data center.
Okay, so I think that's a really important point there about using Consul to kind of manage the endpoint. What did you use as your on-premise VPN endpoint? Obviously in GCP, or sorry, not on-premise, in your kind of former hosting provider. Obviously in GCP, you're using the Google Cloud VPN and using like the cloud router on our side. What were you using kind of in your former environment?
Yeah, actually, we were not using the Google VPN service. That's an important point. Like we were actually using zero-tier to do the VPN. So we didn't have to use the Google VPN gateway server. And I think that's actually an advantage. Like using a gateway server is a lot of work configuration-wise. And one of the big advantages of using zero-tier is that it's very little configuration. You literally just install zero-tier on all the servers. You make it join your private network, and the rest will be figured out automatically. All the routing and everything will be done by zero-tier. So you don't have to worry about setting up the VPN tunnels yourself and routing the traffic. This is really a big advantage of using zero-tier, is that how easy it is to use.
That sounds really cool. Is zero-tier an open source project, or is that a commercial package?
It's both. It's an open source project. It's I think it's zerotier.com. They also offer a service which we also used, but it's available as open source. Okay, should I go on with the presentation?
I'm sorry, I realized I was speaking with my microphone on mute. I was saying that actually gives me an idea that I should probably reach out to zero-tier and have them come on the show to talk about how they help other customers do these kinds of migrations. So thank you very much for teaching me something today. I really appreciate it.
Sure.
And yeah, let's continue.
Okay, so basically, so I use Postgres as an example now to move a stateful service. I mean, stateful services are the hardest to move. It's if you have a stateless application server, it's easy to move it, right? Like the only thing you need to do is change the DNS and then you have moved it. So the hard part is the stateful services like your database and your for example, HDFS. And in our case, we made sure that all state was synchronized to both data centers. For example, HDFS, we would make sure that all data is uploaded to both clusters. So one cluster in the first data center and then one cluster in the second data center. And in our case, this was fairly easy to do because due to the nature of our application, we upload all data is refreshed every 24 hours. So after running all services to uploading everything for 24 hours, we were sure that we would have synchronized data. Of course, we also ran a bunch of integration tests to make sure we didn't make any mistake anywhere. But in the end, it was as simple as that. We just changed our app slightly that it would upload to both places, waited 24 hours, and then we had a completely replicated set of data. And it also kept replicating continuously, like whenever, just nonstop, it would keep replicating all of the data until we could do the cutover for HDFS. And yeah, this brings me to my last slide. Basically, if you just do this for every one of your services, you move the service, you test that everything works, you do the cutover, and if things go wrong, you can easily roll back. You just literally just change the DNS setting and then you've rolled back. So it's a very safe way to do a migration because, yeah, you always just do one service after another and it's really easy to go back.
Awesome, thank you. So a couple of additional questions coming up here. People are interested in learning a little bit more about how you did zero downtime migration of Postgres specifically. And it sounds like the answer to that was really two parts, using console and using
I didn't catch the end of the question. Could you repeat the question?
Yes, of course. So the question that we have is, how did you manage zero downtime migration specifically for Postgres SQL?
Yeah, sure.
Was it just console and zero tier? Were there other things that you had to do? It sounds.
Yeah, you're cutting out a bit, but I can.
That you had to do.
Yeah, I can answer the question. Yeah, so basically, how did we migrate Postgres? Well, the big part of the answer is, via zero tier and console, and you configure Postgres to have a secondary server, which automatically replicates all the data. You need to make sure that you configure it, that you set synchronous commit on. Synchronous commit basically means that everything must be committed on both, also the secondary data server before the transaction returns as successful. So you turn on synchronous commit, and then that gets you almost there. And then the last part of the puzzle piece is to use PG Bouncer in front of your Postgres server because it can queue requests. So you can pause requests in PG Bouncer. So what you do then is you pause the requests in PG Bouncer, then you do the cutover, which means the secondary becomes the primary. Then you can reconfigure PG Bouncer on the fly. You can reload it from disk while it's running and holding requests. And then you unpause, and this will make sure that all requests will then be routed to the secondary database server. And this way you will not have lost a single request.
Very cool. So it sounds like there's a couple of additional things that you needed to use. One, and apologies if I get one, that the data was synced across the two instances, but also then when you did the cutover, that it was entirely seamless and not cause any disruption to the service.
Yeah, we actually have the details about this in our blog post. I'm not sure if you have all the details about Postgres, but like most of the details should be in our blog post on tech.channable.com.
Excellent. And then one more question on Postgres. Are you using the Postgres version of Cloud SQL, or are you just running your own Postgres on Compute Engine?
No, we're actually running our own version of Postgres on our servers, because we were still using Postgres 9.4 back then, and I think Cloud SQL was at a different version.
Got it. Thank you. So I hope this was useful for everyone. We're kind of getting near the time that we try to keep these things to. So maybe I'll just ask you one last question. What are like the couple of things that you think you learned from this migration, other than don't do it big bang and do it piecemeal, then you would recommend that other people that have to go through the same process either follow in your path, or maybe there's some lessons learned that you wish you had done things differently?
Yeah, sure. I think in general, of course, make sure you understand your requirements, make sure you measure everything, measure what capacities you need, what throughput, latency, how much data you need to copy. All of this stuff is good to know ahead of time. And then also stress test this, because this is when things will go wrong, right? Like you need to make sure to stress test everything. And this is why I think it's good to do it piecemeal, because then you can focus on individual services, which is much easier than focus on all services at the same time.
Yeah, that's a great it's a great thing to end on right there. Stress testing is incredibly important, and that's another advantage. Just like you're saying, it's another advantage of doing the piecemeal migration, is you can actually stress test your services individually rather than trying to stress test the entire distributed architecture. So with that said, thank you very much, Robert. Really appreciate the time today. I think this was incredibly informative. Lots of great lessons, both for how to kind of make some of the decisions that go into choosing a cloud provider, how to actually do the migration, and then how to tell other people about it. So thank you so much.
Yeah, glad to be here. Thank you.
All right, everyone out there on YouTube and elsewhere watching this, thank you so much for your time. We'll really appreciate it. Please subscribe, like, and rate, and we'll see you next time on GCP Live.